but I actually remembered today to turn the recorder on just now. So, Cody, you get it all figured out last night?
Yeah, I got it all figured out.
Okay. Well, let's take a look at, let's look at the next assignment first, okay? Let's go to our home page, and I'm going to do a little share here. Okay. So you guys can see this now?
Yep.
So here's the next assignment. Let's click on that. And oh, that's nice. What do I have? Oh, you know what? I think that's supposed to be a 12. Let's try that. Yeah. I had the number. If you click on the link, it comes up as homework 11, but it should be homework 12. So just change that to a 12, and it should download the file for us. So here's a document. I guess it doesn't matter if you get it downloaded or not, but they call this a game. It's not really a game in the traditional sense of a game where you've got some competition going on. It's more of a kind of a simulation, I guess. This goes back to the 1960s, I think. And a mathematician described it in Scientific American. And the guy's name was Conway. And so I think, you know, you can probably Google Conway's Game of Life and it'll tell you about it. So it's not really a game, but it's an interesting problem using two-dimensional arrays. So if you don't feel as comfortable as you think you ought to be with two-dimensional arrays yet, this is another chance to work with them a little bit. So we've got they call it a population on a two-dimensional grid. And I mean, I've always kind of thought of it as like being, you know, like microscopic cells or something like that. But it doesn't really matter. We got a two-dimensional grid, and each cell on the grid is either alive or dead. So there's either something in the cell or there's not. It's a little bit like like the last program we did. Every cell either had a space in it or an X or an O. In this case, each one will have either a space, or I used an asterisk, but it doesn't really matter what you put in there to indicate that it's alive, just so you know which is which. So whether a cell is dead or alive in the current generation depends on whether its neighbors were alive or dead in the previous generation. So you start off with generation 0 or generation 1, and it's going to be some configuration of cells that are alive on a grid. And then you got some rules to figure out what the next generation is going to be. And you display that. And then you compute from that what the next generation is going to be. And you keep on doing that basically forever. So these are the rules. The rules are pretty simple. If a cell has, let me turn this off. Okay. So if a cell has 0 or 1 neighbors, it will be dead in the next generation. And so they're saying it dies from isolation, you know, kind of like if there's a pandemic going on. And if a cell has 4, 5, 6, 7, or 8 neighbors, it will be dead from overpopulation. So it's got a total of 8 possible neighbors. And so we could have any number from 0 to 8. There's 9 possibilities, and 1, 2, 3, 4, 5, 6, 7 of those possibilities end up with it dying in the next generation. If it has exactly 2 neighbors, it will remain in the same state. So if it's alive, it will stay alive. If it's dead, it will stay dead. If it has exactly 3 neighbors, it will be alive in the next generation, regardless of its state in the current generation. And that's the only way that you get new life. Okay. So every cell has 8 neighbors. You know, this would be row -1, column -1. This would be row -1, column. This would be row -1, column +1. This would be row, column -1. This would be row, column +1. This would be the row of the asterisk +1 and the column -1. Row +1, same column. Row +1, column +1. Okay. So for a given row and column, those are the 8 neighbors, and that's pretty straightforward. If you went through the Minesweeper videos that I put out there, the Minesweeper works pretty much the same way. You have to look at all the neighbors and you know, do some evaluations. So our input is going to be a file. It's going to have 48 lines and 80 characters, and I picked those numbers because our grid is 800 by 480. So if I take an array that's 48 by 80 and I want to draw it on the screen, then each cell is going to be 10 pixels by 10 pixels. Okay. The input cells will either have periods or asterisks. If you see a period, it's a dead cell. If you see an asterisk, it's a live cell. And so you should make both of those named constants. Make the 48 and the 80 named constants. And we can try it with other sizes. I've got some sample data out there. If we flip back over to our browser, and okay, click on data files. That's a zip file. And I'm going to extract them all just to my downloads folder here. And you want these to be in your bin folder when you actually run the program and write the program. So here is life1.txt. And it starts off with 2 cells and they die from isolation right away. So if this is generation 1, in generation 2, everything is dead. Life 2, this one's interesting. This one, and you know what, I got kind of a big font size here. Maybe I should go to format and do a smaller font. Maybe I can see the whole thing on the screen. Let's try 10 instead. Okay, so now you can see the whole thing on the screen. And I've got 2 rows in the middle. And if you look at that, almost every cell, except for the ones on the ends, if you're just looking at the live cells, most of them have 5 neighbors, right? 1 on each side and then 3 on the next row. So most of them are going to die. But if you look at the ones that are right above, the dots that are right above that first row, almost every one of them has 3 neighbors. All 3 of the ones below. And so this row above the asterisk will be alive in the next generation. The same thing happens down here. This is precisely in the middle of our array. And so what we're going to get is it's going to be symmetric. Whatever you see on the top side, you should see on the bottom side as well. And this one goes for a long time. It never dies out, but eventually it stabilizes. There are some patterns in there that stabilize. Let's go ahead and close this. We've got life3.txt. And this one is some patterns that repeat. This one I remember what it does off the top of my head. Every one of these has 3 neighbors. If you got a little 2x2 group, everyone has 3 neighbors, so they'll all stay alive forever. So that's a stable pattern. But the guys in the corner here, the top corner of the bottom one, and in the bottom left corner, of the top one, that's where the two squares meet here, they've each got 4 neighbors, so they die. But then on the next generation, they're down to 3 neighbors, so they come alive again. And what you get is it basically those two flash on and off, and everything else stays the same. This one, I think is called a glider, and what it does is it goes through a number of cycles, and it gradually moves across the screen. I think it moves across and down. And these up here also do cycles. They end up back where you started. Let's close out of that one. Let's open up Life 4. Those are some more stable patterns. Let's open up. And then I've got Life 5 by 5. And if you look at this one, it is just 5 rows and 5 columns. And that one is there for debugging purposes. If you have an 80 by 48 array, I don't know, let's do 80 by 50. 80 by 50 would be 4,000 cells. So you get about 4,000 cells to look at there, and you probably don't want to look at 4,000 cells. What you want, in this case, I've only got 25 cells to look at. And so if you're trying to debug this one, it's easy to go stop the program, look at the array, see where the asterisk and the periods are, and figure out why your program isn't doing what it's supposed to be doing. If you take a look at that particular pattern there, there's another reason why I've got that particular pattern. That particular pattern, if you look at I'm going to number these from 1 to 5 instead of 0 to 4. So if you go down to the second row from the top, and the one in the middle there has 3 neighbors, so it will be alive in the next generation. The 3 that are on the row, the 2 outer ones only have 1 neighbor, so they're going to die. The one in the middle has 2 neighbors, so he's going to stay the same. And then if you go to the 4th row below the asterisks, you've got the same situation there you had on the top. The 3rd one over is going to have 3 neighbors, and he will be alive in the next generation. So what you get is, in the current generation, we've got 3 going across. In the next generation, it's going to do a vertical 3, sharing the same middle spot. And in the next generation, it's going to go back to where it started. And then it's going to go back, and I kind of call that the jumping jack because it bounces back and forth between those same 2 positions. You get 3 horizontal, 3 vertical, then it goes back to 3 horizontal, 3 vertical, over and over and over again. Okay, so it's easy to tell if you're updating it correctly because you'll get that flashing horizontal and vertical repeating over and over again. And it's easy to debug because you've only got 25 cells that you have to look at. I did put a couple of other Life 5 by 5 ones out there. Let me see. Yeah, so I think that one, I think it flashes in the middle. And this one, that stays stable forever. Each one of them has 4 neighbors, so they stay that way forever. So I'm going to close that. So those are different files you can try. And then on my homepage, I've got some links. Let's go to the video here. This is on YouTube. And you can either, follow it yourself or you can just watch mine.
Without a college degree, I was just fighting an uphill battle. I found Google's IT support program. I finished the program.
Okay, now, the one we're doing, I said, is 80 by 48. So each cell on the screen is going to be 10 by 10. This one, each cell is 1 pixel. So we're looking at a massive number of cells here. And I think it just started out at the very beginning. I think it just starts out with this big X. Yeah, it starts out with an X, and then it just goes from there. Okay. Now that whole thing is 6.5 minutes long, so we're not going to go through the whole thing, but that's pretty intricate just from those 4 simple rules that we started off with. Let me back up here, and I've got a few other videos out there that we can check. We'll probably get another ad here too. Okay, so some of these patterns just go forever. So here's a question for you to ponder. Who had enough spare time to try to figure all this stuff out? So those are some videos that were on YouTube already. This is a video of our Life 2 file, the one that starts off with 2 horizontal rows of dots. So this one's actually my program. And I've got it updating like, I don't know, every half second, I think. So I'm going to slow it down a little bit here to 1/4 speed. And right, so we should see almost all of them are going to die off because every one of them has 5 neighbors, except for the ones on the ends, and the ones on the outside, the top row and the bottom row here each have 3. So if I go to the next step, okay, most of those died out except for the ones on the end and the row above and the row below. Now, most of these have 2 neighbors, so they should stay the same, but their ones above and ones below are all going to have 3 neighbors, so we're going to end up with like a block of 6 rows here, I think, on the next. Yeah. Now, these are all going to die out in the middle because they've got too many neighbors. I don't know where that background sound came from on that. But you start seeing it stabilize. That stabilizes. The 82 by 2 is going to stabilize. This is a shape that stabilizes, kind of looks like the letter D turned on its side, and this one. So eventually, I don't remember how many. I don't remember how many generations we had to go through, but eventually it stabilizes. So if you do the life2 file and, you know, go through all these generations, your program should end up in the same state that mine does. It should look, darn it, I just, a little too slow. Should end up looking like that. Okay. Now, if you run your program and you get that at the very end, I'm pretty sure there's a 99.9999% chance that everything is right. Let's back up one, and there is another video I put out there of a 480 by 480 grid. And this is my program, and so yeah, we should get kind of the same thing we did in that other one. But it only took 1 or 2 changes to my program for this to work. All I had to do was change the number of rows from 48 to 480, and the number of columns from 80 to 480, and then read in the data from the file, and then everything works. So if you run this for a while, I don't think this ever stabilizes. So I just ran it for a minute. So if you do a bigger grid with more pixels or more cells, then you start getting some more intricate patterns. Okay, let's go back. So let's go to our Word document for that. And we're going to have to read in a file, something we have not done before, but you've done it in Python. It's not that big a deal. I created a cell structure, cell struct, that would hold either an asterisk, and I did a space for dead. You could use a period for dead as well, and a rectangle telling where that cell is supposed to be drawn. And then I'll have a 2-dimensional array of those. And in each position in the array, I can either put a live cell or a dead cell, whatever string value I choose, you know, this or this. And I can also, at the beginning, I can compute where the rectangles go, and they will never change. So we want to write functions instead of writing the code all in one big update. So I want you to write a function to initialize the board, and basically all you do is you pass in a 2-dimensional array of cell structs. You set all of the strings to blanks, and you determine the X and the Y coordinates of the cell on the screen, and you can determine the height and width, which in this case will be 10. Now we need to keep track of 2 generations here, because you can't update the current generation in place. If I do, I'm changing the number of neighbors that somebody has as I'm going through the update. So what you have to do is you have to have one array that has the current generation, and then as you go through and you figure out what the next generation is going to be here, you copy it over here and you don't mess with your original one. So you go through every cell over here and you figure out what's going to be the next generation, you copy that value into the other array. Then when you get all done, you copy all those values from one array, from the next generation array into the current generation array, and you start all over again. We will have one function to read the board, one function to display the board, one function to update the board, a function to count the neighbors. So we'll pass in the array, the row and the column, and if we know the row and the column, we can figure out what the row and column numbers are for the 8 neighbors, and we can count up how many neighbors it has, okay? Our our program will only have two states. We'll have a paused and a playing state. When they press the start button or the enter key, we'll toggle states. So if you're in the pause state, you go to playing. If you're in the playing state, you go to the pause state. When the game begins, you'll be paused, and you wait for them to hit the start button or the enter key. And then eventually you will, if they pause, then you'll flip back, and you can just go back and forth forever. And we're only going to change states, you know, when it was released on the previous one and it's pressed on the current one. Otherwise, you know, you'll get there real quick, 60 times a second, it'll be flipping back and forth. We're going to use the entire display to display our cells, so they'll be 10 pixels by 10 pixels, and that's it. Okay. So the big thing here that is new is reading the data in from a file. Okay, so I've actually got an example that I was planning on doing today, but I think I want a simpler example. So let's go into actually, let me look at that example. Okay. So yeah, we'll do this one. So here's what we have. We have an input array that looks like this. I should have said file. We have an input file that looks like this. What's on the first line is an integer telling me how many rows there are of data. And what's on the second line is an integer telling me how many scores there are for each person. Okay, so we got 5 scores for John, 5 for Paul, 5 for George, 5 for Ringo. And if I know what these two numbers are, then I can have a for loop that reads in 4 lines. And if I know what this number is, I can have another for loop that does all 5 of my numbers for me. Okay. So what we want to do is we just want to be able to read that in first, and then I've got a whole bunch of things we can do here. I don't think we'll have time to do all of them, but we can do some of them for sure. So we're going to read this number in. It's going to be a string. We're going to convert it to an integer. We're going to call it rows. We're going to read this number in. It's a string. We're going to convert it to an integer. We're going to call it columns. Then we're going to read in a line here. And the tricky part, something that's new today, is getting that line split up into a name and 5 numbers. And there is a built-in function called split. And what split will do is it'll take a string and it'll split it up into pieces based on the spaces that are in it. So if I take this line and I tell C# to split it, then it will give me 6 strings. The string John, the string 100, 99, 98, 97, and 95 in an array. So it basically takes one string and splits it up into an array. It's a really handy function. Okay. So let's take this right here. Let's just copy this. We're going to make our own file. Do a Control-C. And then let's go to Notepad. You don't have Notepad on your toolbar down here like I do. Just go to search and type in NO is probably enough. Paste it in. Now, before we save this, let's make sure we got a place to save it. So fire up C#. And okay, so here's C#. Let's put this in over here. And I don't need this. I'm going to do, let's create a new project in C#. And it's going to be a console app. And we will just call this read names and scores. So that should have created a folder for us called read names and scores. Wherever you're putting your stuff, whether it's on OneDrive or on your local hard drive, there should be a bin folder out there now for this project. And if we want to be able to read that file without providing a bunch of path information, we want to put that file in the bin folder. So now let's go back to Notepad and let's do File, Save As. And mine is on OneDrive, so I've got to go to OneDrive, and I've got a folder out there called, actually it's called Mono Game Programs, and this isn't a Mono Game program, but I'm putting all the stuff for this class out there. So I got something called My Mono Game Programs 2020, and if I sort these by date here, read names and scores should be the first one. So double click on that, open up read names and scores, open up bin, debug, and let's call this scores, keep it short. TXT will automatically be put on for a file extension by Notepad. So go ahead and save it. Then we don't need Notepad open anymore. So it looks like you might still be catching up. Let me know when you're ready to go.
I'm good. Okay.
Casey?
Yeah, my Visual Studio's frozen again, but I'll catch up.
So we're going to delete the stuff here that we don't need, the hello stuff, hello world stuff in the comments. And we're going to delete this last line down here and just open up a few blank lines there and push read key down. Now let's flip back over to our Word document. So here's what I want to do. I want to write all these functions. I don't think we'll have time to write all those functions today. But this is stuff that I want to put in my main method. Okay, and we're going to do this in two steps because the structure here, the declaration of the data type has to be outside of my main program. It has to be above my main program. So let's do a Control-C on that, flip back over here, and it needs to be above main. Then flip back over to Word, and I've got a bunch of code written for you here. Actually, let's just take the first 3 lines. Copy them, and this goes in the body of main now. How's everybody doing? correct?
Okay.
Okay,
Yep.
everybody good?
Yeah.
Okay. So let's look at what read data would look like. So it's going to be static, void, read data. And then we're going to pass in this array of structures. So we haven't done anything like this before, so let's take a look at this. A struct simply lets you combine different data types together. You can bunch a bunch of variables together. And what I want to do is I want the name from the first part of the line, and then I want the scores from the second part of the line, and I want to put those in an array. And then I'm going to have an array of those. So the first element in my array will be, I think it was John. And then the second one will be Paul, and then Ringo and George, whatever the order was for them. But this will be, this variable right here is an array of student structs. So I'm going to have 4 of those when I get done because I've got 4 students. So let's do our read data here, and ref student struct. And we'll call it student again. So I want to read from my data file here. So I need a stream reader. So we need to go up here and do using. Got to spell using right. Using system.io. Then down here, we need to declare a stream reader. I'm just going to call it file. You can call it whatever you want to. I'm going to call it file. It's a new stream reader. And what do we call it? Scores.txt. Let's go to lookout on disk for a file called scores.txt. And it's going to let me read from it. Now, I know a little bit about the structure of the file. So I can declare an integer variable called rows. And I'm going to read in from the file, that first line. Problem is, whatever you read in from a file is always a string. And I'm trying to put a string into an int. So the way you fix that is you do that convert. Let me put a blank space in there. Convert dot to int 32 is what we want. That's the typical integer. And then the next line has a number of columns on it. So int cols equals convert to int 32. And then I want to do another read line. So, you know, before we go too far, I kind of like to know if what I'm doing so far is right. So let's do console. I'm sorry, not read line, write line. Okay, Casey, you good?
Yep.
Brooke, you look like you're done.
Yep.
Cody?
Yep.
Okay. We're almost ready to go, except for this little red wavy line here. And if you pause the mouse, it says, we're passing in an unassigned local variable called student. And it wants us to initialize that before we go. So let's do student. It's an array. So we're going to do new student struct. And it doesn't really matter what we put there because down here we're going to have to reallocate the memory for it. So let's go ahead and run this program now. We should get a 4 and a 5 printed out. And there we go. Took a while, but I got my 4 and my 5. Did you get it?
Mine's not working.
That's weird. It doesn't like my namespace for some reason.
What's the error message you're getting?
It says expected, but it's looking for a semicolon.
After IO?
Oh yeah. Okay. I was like, what the heck? Okay. So it's like there's never a semicolon over namespace. But yeah. Okay. Thank you.
Yep. Yeah, using up there will be. Okay. Now does it run?
Yeah, it's taking a second.
Working, Cody?
Yep, mine's working.
Lisa, you said yeah? Okay. So now that we know that it's working, at least we're getting the first 2 numbers correctly. Now what we have to do is we have to reallocate memory for our array. I wish that you didn't have to do this because this is just, the only thing we're doing this for is to satisfy the compiler. So we've got some memory allocated before we come here, even though we're going to reallocate it right away. So let's do student equals new student struct. And then I want to tell it how many rows I want to have in this array. And it's the variable rows. So this is going to set aside 4 rows of memory for me. Let's put a breakpoint right on this last curly bracket here at the end of read data. And then let's run the program. And I just want to do that so that when we get here, if we pause the mouse over student and click on the little arrow there, it should tell us we've got 4 elements numbered from 0 to 3. Everybody got it? So it's working? Okay. Let's stop the program. Okay, now I know how many rows there are. I want to read 1 row at a time. So let's do for r equals 0, r is less than rows, r plus plus. I'm going to take off my breakpoint for now. So what do I want to do in here? I want to process 1 row, right? And what's 1 row look like? It's a person's name followed by 5 scores. So we're going to read in the entire line. I think I closed Notepad, didn't I? Yeah, I did. Okay. So that's nice and big. So that's my data. And what I want to do is I want to read in that first line. Okay. So I want to read all of this in. I'm just going to put in a variable called line. So I'm going to declare it right here. String line equals, and how do you read a line? It's going to be file dot read line. The first time I do that, it's going to read this entire line. I'm going through the loop 4 times. So the next time it's going to read this. Next time it's going to read this. The next time it's going to read this. Now, so just keep in mind here that the only thing we have to write in this for loop is what to do with one of those lines. Okay. So I want to take those, that name and those 5 numbers, and I want to pull them apart. And there's a really slick way to do that. We're going to declare a string array, and I'm going to call it token, because when you're parsing a line like this, they're frequently called tokens. And it's going to be line dot split. So let's take a look at what's going on here. This means I'm going to have an array of strings, and the name of the array is going to be token. And I'm going to go to that line that I just read in, and I'm going to split John into the first element in token. I'm going to split 100 into the second element, and then 99, 98, 97, 95. They're all strings right now. But the neat thing is I didn't have to go break them up myself and find out where these gaps are. It just all happened for me. So let's put a breakpoint here on that closing curly bracket for our for loop. And that for loop's only going to get executed 4 times. So let's go ahead and just start it. And if you'd rather just watch on mine, you can do that too. So we'll start the program. And we get a breakpoint here. And now if I click on token and click on the little arrow, you see what I've got in element 0 in the token array is the name John, and then 100, 99, 98, 97, 95. So I've got all of my strings broken up into an array. I could have done that myself, but it would have been a lot of work. So we're letting the system do a bunch of work for us. Now, if that's what my array looks like, then element 0 has the name. And actually, I'm going to run this again. I'm going to tell it to continue. And the next time through, if I pause at token and click on it, now I've got Paul and his scores. If I were to do that 2 more times, I get George and Ringo as well. So let's stop our program from running. And now what I want to do is I want to get the data from this input file, and I want to put it into my student array. So student is an array. It has 4 elements in it, 4 rows, and I'm currently on row R. And row R, or any row in here, is going to have 2 parts. It's going to have a string, and it's going to have an array of scores. Okay, so the first thing we want to do is we want to do a dot and type N for name, and I'm going to get that out of my token array. It's in position 0 in my token array. So my token array is this, and this, and this, and this, and this, and this, okay? And we just pulled off element 0. Now we need a loop to go from, you know, this is element 0 in my tokens. This is element 1, element 2, element 3, element 4, element 5. And so I need to go through a loop 5 times, take this out of element 1 in the tokens array, and copy it into my array of scores over here. So I need a loop. And my loop is going to go C equals, whoops, int C. So here's my token array. Element 0, element 1, 2, 3, 4, 5. What I want to do is just forget about the name here, and I want to end up with these 5 numbers in my score array for this student. So I need a loop, and that's what my loop is for right here. So what I want to do is I want to, the student I'm on is student sub R, and they have a score array, and every time you deal with an array, you've got to allocate memory for it, okay? Now, I allocated memory for the big array that has 4 students in it, but each element in that array has a student struct, and part of that student struct is another array. So what I'm saying here on the first pass through the loop is for student 0, I need to set aside, I need to allocate memory for that array. So it's going to be new, and it's an integer array, and it's going to be cols. When we read that up there, we said there's 5 columns, which means there's 5 scores. So this will give me a new array. This is one time I wish I really had a whiteboard so I could draw some pictures of this stuff. So that sets aside memory for 5 scores, and I put that in the wrong place. I don't want to do that 5 times for each student. I want to do it once for each student. So do a Control X and go up here and paste it above the for loop. So when I'm going from here down to here, I'm working on student R, okay? So I give student R's name, the correct value, and then I set aside an array with 5 spaces in it for the scores, and then I got to go get the scores, okay? So the scores are in for student R, he has score C. And I'm getting that from my token array at position C+1. This seems like it's getting really hairy. Does it seem that way to you guys? Okay, so let's back up. This is my input line. So when I do this line read right here, that goes into the variable line. This line takes it and splits it up into 6 parts. Okay, they're all strings though. And then token 0, this is my token array. right here. My line this stuff gets converted into an array of strings. So instead of thinking of it as the input file now, think of it as the token array. And I need to take token number 0, which is John, and I need to put it into the name field for my current student. My current student is student sub R. Then I need to set aside some memory for an array for student sub R, and it has to have 5 elements in it. So think of this as being my array, and I want to take these strings up here and I want to convert them into ints and put them down here. Well, these are positions 0, 1, 2, 3, and 4. Up here, though, the positions are 1, 2, 3, 4, and 5 because John is taking up location 0 there. Okay, so if I want to get score C, I can't click down there without losing my notepad. If I want to get score C, and C is 0, that's the 100. But that's location C plus 1 in my tokens array. And if I want to get the second item, that's position 1 in my score array, but it's at C plus 1 up here. So I'm going from 1 to 0, position 2 to 1, position 3 to 2, position 4 to 3, position 5 to 4. Okay, so that's why I have to have C plus 1 here. Otherwise, I'd end up putting John in for the first score. And I'm getting error message here. The reason I'm getting error message is because token is an array of strings. So this is a string, but what's my score? My score is an int. And so I need to do convert to int32.
Tom, is that convert statement different than the typecasting we did where we just type int and then parentheses around what's after it?
Yeah, it seems like they're almost the same thing, but if you try putting int in front of it, int doesn't work if it's a string that you're trying to convert. Int works for another numeric type.
Okay.
Okay. Kind of seems like it should though, but it doesn't. It did in Python, didn't it? Except we didn't. The syntax was a little different, but yeah, you have to do the convert if you're going from a string to a number. Now, I don't know if you guys still have a breakpoint there or not. I want a breakpoint on the closing bracket for the for loop. So what that means is we'll do student number 0, and then we're going to stop and take a look. Then we'll do student number 1, and we'll stop and take a look. Okay? So you ready to go? Let's run it. Okay, so here's my breakpoint. And now if I pause my mouse over student, it just tells me that it's an array with 4 elements in it. But I think if I highlight student sub R and pause the mouse over it, it still just tells me the same thing. Let's try. Okay, so select score sub C and pause the mouse over it and then click on your expansion arrow there. And it will show us, I lost it when I switched. It will show us the scores. And, you know, so 100, 99, 98, 97, 95, those are the scores that were on that first row. And if I look at student sub r.name, I think John was the first one, right? And it shows me that that's John. So The data structure is a little complicated here, but on the other hand, it's all perfectly logical. We have these things called student structs that are made up of a string called name and an array of scores. So 2 parts. I want a bunch of those. So I have to declare an array of student structs. And every time I go to a different element in the array, I'm going to a new name and a new array of scores. Okay. So down here, when I go from R, set R equal to 0, then I'm doing student 0 name, I'm doing student 0's score array and allocating some memory for it, and I'm doing student 0's 5 scores as I go through this loop 5 times. Okay, so the double subscript thing here might look a little funny, but this tells me which student I'm going to. And then when I get to a student, that student has an array of scores, and I've got to be able to go to the correct item in the array of scores as well. Okay, go ahead and click continue. And the second input line was Paul, and his scores are mostly in the 80s except for a 75. So if I pause the mouse over name, it tells me it's Paul, and that's for student 1 because R is 1. And if I pause the mouse over score here and open it up, it gives me the 80, 85, 80, 75, and 80. So now I've got Paul's scores. Let's run it again. This time R is 2. And if I pause the mouse over name here, the name is George. And if I pause the mouse over the score here, I might have to select that first. And those are the scores for George. And then one more time, we should get the scores for Ringo. If I pause the mouse over here, the name is Ringo. If I drag the mouse over my scores reference and pause it, click on the arrow, those are the scores for Ringo. So we've just read in our data. Now, what you guys are going to have to do on your life program, let's go to File, New, whoops, I'm still running. Let's go to File, New, Project, and we want a mono game project, Windows, and let's call it Life 2020. Okay, I did not give you any code for the life program, but we can write a little bit right now. So let's go over here and open up game 1 and get rid of all these comments that are cluttering stuff up here. So we're going to have an array of cells. So let's do a struct, and we'll call it cell struct. And our cell struct is going to be made up of two things. It's going to be a string and I'm just going to call that cell. And that's where we're going to put the star if it's alive, or a space if it's dead, okay? And public rectangle. And this will be the location on the screen to draw the cell. And then I need some constants. And I'm going to add two more. And then I need a two-dimensional array of these. So it's going to be cell struct. It's two-dimensional array, so I need bracket, comma, bracket. And let's call this, I already used the word cell, so I don't want to use that again. Let's call it grid. And I think I can allocate memory for it right here. It's going to be a new cell struct with rows and columns. Now let's figure out where to draw those on the screen. So let's go down to initialize and let's write an initialize function. So we'll call this initialize grid, which is probably not what I called it in the problem description. So this is going to be void. And I want to go through every row and every column in that grid. I want to put a space in there to indicate that it's dead. And actually that reminds me of two other constants I want up here. Constant string alive equals star, and constant string dead equals space. And then throughout the program, we just refer to alive and dead. We don't need to refer to an asterisk and a space. So now in initialize, I want to go for R equals 0. R is less than number of rows, R plus plus. And then for C equals 0, C is less than row or columns. And what do I want to do? I want to make the cell a dead cell. So grid at this row and this column dot cell equals dead. And then I got to figure out where to draw it on the screen. And this part is exactly what we did in the tic-tac-toe program. It's exactly what we did in the Minesweeper program. So the grid at this row and this column, its rectangle is going to be equal to, the X is going to be the column times, I'm just going to put 10 here now, but I don't want you to leave it like that. Column times 10, and the height is going to be the row times 10. And the width is going to be 10, comma 10. I forgot to put new rectangle. Now, these 10s here are just the size of a cell. So let's do one more variable up here. Let's do an integer called cell size. Equals screen width divided by cols. So 800 divided by 80 will give me 10. And then down here, change the 10s to cell size. Oh, I forgot an extra plus sign on the end there. And down here, I forgot the C. Must be this new keyboard. Okay. It is 1:45. If you can hang on a couple minutes, we could just draw the grid, what it would look like if everything was alive. If you can't stay, that's fine. I'll keep on going here. Let's open up content and run our content program here. And somewhere out there, we should have a white circle. I think I probably have it in one of my other programs here. I just need to figure out which one. Pong. Pong, I had a white square. So if I go to my Pong and I go to my content folder, there should be a white ball. I'm gonna open that up. Copy it to the library or the directory. And then I'm going to compile my pipeline. Close it. Make sure I add it to my project. And it's in my content folder. I want to see all the files that are out there, and it's white ball. I've got two things I need to do. I need to read in the texture. So I need to declare a texture variable. So I'm going to call it ball texture. And then down here in load content, my ball texture So I load the ball. And then down here, all I have to do is sprite batch dot begin, sprite batch dot end, and then I want to draw every single one on the screen. So for int r equals 0, r is less than rows, r plus plus, and for c equals 0, c is less than cols. Whoops. And what I want to do is I want to draw that ball on the screen. So sprite batch dot draw, and I want to do the ball texture. I want to do the rectangle for what do they call it, board?
Grid.
Grid, that figures. Dot rectangle, and I'm going to make them red. What? Did I clear a texture instead of a texture 2D? I did. And down here, here I called it 2D. So it needs to be texture 2D all the way throughout. Are you ready to run it?
Not quite.
You want me to leave my code there?
Yeah.
Okay. If you got the code in, go ahead and run it. Brooke, Cody, or Casey, does it run?
I'm still typing, sorry.
Am I supposed to? Let me see if I can. It's supposed to look like this.
Is there
Oh, you probably can't see that.
40 rows of red dots?
No, it's. It looks like a bunch of. Looks like a red background with a bunch of plus signs on it.
Oh, yeah, because we made them fill the whole thing. So the plus signs are actually the background.
Yeah.
And if we go up here and we do cell size, let's do cell size -2 for the width and the height. Yeah, I remember the first time I saw that, I thought, well, that doesn't look right. Cody, you ready to go?
I should be.
Brooke, yours running?
Yes. I think it's still loading.
Yeah, mine's, I think, working.
So I made the rectangles a little smaller, so there should be a gap. So you should actually be able to see a bunch of circles here instead of, there we go. And I left the cornflower blue for the background. So you might want to make them like, where did I put that? Cell size -2. So that there is a little bit of a gap. Otherwise, they're all touching. And like you
Wait.
said, it looks like a bunch of plus signs.
How did you change them from the, mine are the plus signs too. How did you say you changed?
Up here, when we initialized our grid,
Yep.
we made it 10 by 10.
Yeah.
And I did the -2, so it's 8 by 8. So there should be like a 2 pixel gap all the way around.
Okay.
And I'm gonna do, instead of cornflower blue, I'm gonna do white. Whoops, I gotta stop my program first. And I'm gonna run it again. There we go. And obviously what you're going to do down at the bottom is you're going to have an if statement that says if the cell at that row in that column is alive, you know, if it has that asterisk in it, then you draw. Otherwise you don't. And probably the trickiest part of this program will just be reading everything in. You don't need to use that split because it won't work on this particular data file. What you do is you read in a line of 80 characters, and then you just have a loop that goes from 0 to 79, and you take off a substring at position 0 that's 1 character long. Then you take off a substring at position 1 that's 1 character long, and a substring at position 2 that's 1 character long, and you put those into the corresponding cells in your two-dimensional array. And I strongly encourage you, oh, I want to show you something cool here. You don't need to do this on yours. I'm just going to change the number of rows and columns to 5, which is what I encourage you to do. So, wait a second. 5 rows and 5 columns. That doesn't look like 5 rows to me. What did I do wrong? Oh, I was assuming that it was going to be square. I can't do that. Yeah, I need to do a cell width. Is going to be the screen width divided by columns, and it's going to be the screen height divided by the rows. Okay. So if I do that, then down here, this has to be multiplied by cell width. And this needs to be multiplied by cell height. And then this is my width again. And this is my height. I forgot to capitalize my W. So now let's run it. There we go. And they're going to be stretched out because I'm doing 5 by 5 and I'm dividing 800 pixels by 5 going across, but I'm only dividing 480 by 5 going down. But you could run life there, and when you did, it would start off with, my mouse won't show up, but it'll start off with the 3 middle ones in the middle row, and then it'll jump to the 3 middle ones in the middle column, and it'll just jump back and forth between those two. Okay. So if you work on your program like this, you know, then anytime you want to stop and take a look at your grid, it's only going to have 25 elements in it.
I don't understand how we would pick out the substrings like you were talking about of the lines we're reading in without reading it in as a, or like splitting it.
Okay. I'll show you. So we need a stream reader. Oh, and we don't have I/O up at the top. So we're going to read from that 5 by 5 file. And then we're going to read in 5 lines. So 4, whoops. So I'm going to read 5 lines. And each pass through here, I'm going to read it in 1 line. So let's do a string variable called line equals file dot read line. And that'll give me those 5 characters. So if I were to pause here right now and run it, the first time through, I would just get 5 dots. And the second time I get 5 dots. Next time I get a dot and 3 stars and a dot. And the last 2 times it'd be 5 dots again. So I got 1 line here, and it's got to go in that row in my 2-dimensional array. So now what I want to do is I want to go across that row. And what I want to do is I want to go to my grid. And then I want to do a substring. Now for that to work, we have to copy that live 5x5 file into our folder, our debug folder. So mine is probably in downloads, I think. Life data. I'm going to take all of them, and I'm going to go out and I'm going to put them in my whoa, something's not quite right here. Live 2020. Windows. I got some extra stuff in here. I'm not sure where all this stuff came from, but I think this is where I want to paste it in. Where's paste? So copy that 5x5 file into your folder and put a breakpoint on read file. We better call read file though, otherwise nothing's going to happen. And did I allocate the memory for it? I did up here. Okay, so we're good. So I'm going to try to run it, and I'm going to pause it. At the end of each line, and if I look at my grid, I want to look at the cell. So like highlight that, can I see the whole thing? Oh, it's a struct, and it's just telling me there's a struct there. It's not showing me the actual values. And I don't know if I can do that. No. No, it's not letting me see everything I want to see. There may be a way to do that, but I'm not sure what it is. Anyway, this code should work for you, and we'll find out if it works. I'm going to stop the program. Are you guys all up to speed on that?
Yeah, mine doesn't.
Where do you put the? Oh, go ahead.
Sorry. I have Stream Reader typed in, but it's saying it doesn't recognize it at all.
Can't do that without System IO up at the top.
I'm a little behind.
Okay.
Where did you copy the Life 5x5 into?
It should be in your debug folder.
Okay.
So if you go and find your project, mine is on OneDrive. And it's mono game programs and Life 2020, Life 2020. And then under it's usually under bin, isn't it?
Mine's not under bin, yeah.
Properties. Not under content. So go to bin. Now I've got this Windows folder in there that's usually not there. And then go to x86 and then go to debug and put it in. And I've got all this other stuff in there that I've never seen before. And I'm not sure why that stuff is there, but I think this is the folder it's supposed to be in. I'll find out soon enough when I run it. But before I run it, I want to go down here and I just want to make one little change. If grid sub r comma c dot cell equals alive, then I want to draw it. Okay, otherwise I don't. So what I should see on the screen now is 3 horizontal red squares halfway down and with some space around them on the outside. So let's go ahead and run this. If it's finding my file correctly. There. Are you getting that?
Hey, Tom, can we go up to the read file function?
Right there.
Yeah.
You still have to add that to content, like that Life.
The white circle. What is that? What I called it?
No, I'm saying the Life 5x5 because mine says it doesn't like something with that line.
Not the content folder. It is the bin. I'm sorry, the debug folder. So
Mine says it could not find file.
okay. You need to go to OneDrive or wherever your program folder is.
Yep.
And go to, so mine's called Life 2020 X. And then there should be one inside of that with the same name. Inside that, there should be a bin folder.
Yep.
And do you have a Windows folder inside of that?
Yeah, I do.
Okay. I didn't think that was usually there. Double click on that. And then the x86. And then debug. And that's where
mine's right at the top there.
What's that?
Mine's right at the top there.
In your debug folder?
Yeah.
And you've got life5x5.txt?
It doesn't say .txt after it, but
well, it's there. You must have, on your view tab, you must have file name extensions turned off.
Yeah.
Okay, so if you turn that on, the TXT should show up. The only thing I can think of then is, are you sure you spelled everything correctly when you were telling it what the name of the file was?
I can check it. Okay. Seems to be, but I'll try it again.
We might have to share screens later on.
Yeah.
So just one thing about the grid, you never have to check the outside row of cells. The top row, the bottom row, the left row, the right row. And the reason for that is because they don't have 8 neighbors. So we're going to assume that those are always dead. We're never going to check them. And if you do that, then you can assume every single cell has 8 neighbors. You don't have to have special cases for the edges or the corners. And if you look at the Minesweeper program, that's exactly what I did in the Minesweeper program. I left the border all the way around the outside that I didn't use. So I would encourage you to go look at the Minesweeper program and see how I did that. But I didn't think that was going to take 25 minutes extra, but it did. So we can call it quits for today. And I'm happy to talk about this more on Thursday as well. Casey?
Yep.
I think I had the wrong stuff there for downloading MySQL. I put a video on our homepage that shows how to do it again.
Okay.
So they've got a bunch of different versions of it, and I think I picked the wrong one the first time. So, okay, anything else?
Mine's saying that it's highlighting where it says grid, the last line of the function, and it's saying that the index and length must refer to a location within the string.
Okay. Can you share your screen with me?
Yeah.
If you want to, you guys can log off.
Okay, see ya.
Mine's saying the same thing, so I'm gonna wait and see.
Okay. So are you sharing, Brooke?
Yeah, it says I can't share it while you're sharing.
Okay. I'm turning mine off. By the way, you like the supercomputer I bought?
Yeah.
I got tired of doing things like Pong and stuff like that. Decided to do nuclear physics for a while.
Huh.
Okay. So stream reader, rows, CSS and column. Okay. This is correct, Brooke. Stop your program from executing and scroll up to your constants up at the top.
Okay. You
didn't change them to 5 by 5 rows and 5 columns.
Oh, okay.
So on lines 21, 22, no, not there. Not there.
Oh, yeah. You're right.
The rows and columns are 5 and 5. The screen width and screen height are still going to be the same number of pixels, okay? And then now you should be able to run. I think it'll work. So you're trying to read 80 columns.
Yeah. Well, I'm getting this now. Oh, it's probably in my draw statement.
Yeah, now you just need to add the if statement and only draw it if it's alive.
Okay.
Mine's working. Mine's working.
Okay. Sounds good. Okay, the R didn't come up for you because you're not in the loop anymore. You need to put that above your draw command, and you need curly brackets because we're doing 2 things inside that inner loop. So
All right.
go to the end of row 91.
Okay.
91. No,
Oh,
that was 90. Go to row 91.
okay.
There. Enter. Open curly bracket. And put the closing curly bracket down below the sprite batch.draw. Now you need an if statement.
RNC is live, right?
Now that's a structure. You got, it's not just grid, it's grid RC dot cell.
Oh, yeah. Okay.
If that's equal to alive. Okay, now run it.
Okay, I got it. Cool.
There you go. There you
All
go.
right, thank you.
Okay. So you good now?
Yep, all good.
Okay. I'll sign off then.
All right, see you later.
See you Thursday.
Yep.
Maybe sooner.